In this video, we talk about the geometry, advanced, and ID sections of the standard surface shader. I have this shader network applied to all the geometries in the scene. For now, unhide this cube and hide the shader ball. Add a point light to the scene and place it right inside the cube and set its radius to something like 0.5 centimeters so we have a spherical light. Now let's open up the shader network and go to the geometry section. Run the IPR and turn off the Arnold sky as well. So the only available light is the light that is inside the box. Now, thin-walled allows you to simulate translucent surfaces that allows light rays to go through it, and it can be used for shaders such as paper or leaf. It is recommended that this only be used with thin objects. You notice even though we have this light inside the cube, but the light rays can't go through the surface and illuminate it. So if I enable this thin-walled, and for this to work, we need some subsurface scattering as well. So increase the subsurface scattering weight to something like 0.1 maybe. Now, if I turn off the thin walled and turn it back on, you can see how it makes the light rays go through it. So for thin shaders like leaf and paper that the light rays should be able to go through, you can use this option. For now, turn off the point light and turn on the sky again. Here we have this cutout opacity, and this is exactly like alpha channel in Cinema 4D. Unlike the transmission, which kind of make it possible for us to have transparency, but there the material still considers diffuse, specular, etc. if we use transmission. But opacity will affect the entire shader. When the color is set to white here, the shader is fully visible and opaque, and as I darken the color, the shader becomes less and less visible and more transparent. You can obviously use a texture here. So if I use a checkerboard texture and set its frequency to something like 5 and connect it to cutout opacity input. Now where the map is white, the shader will be fully visible and opaque, and where it's black, the shader will be fully transparent. Next, we have this normal input, which we have been using throughout this course. This is where you connect your normal or bump map. In a later lesson in this section, we cover bump and normal mapping in depth. Let's take a quick look here. For now, hide the cube and unhide the shader ball again. Add an image node and load this wood parquet BW02 texture and set its scale to something like 2. Now you don't connect the image directly to the normal input because you need a way to control the amount of bump and normal mapping. So we connect this image to a bump 2D node where we can control the amount of bump mapping, and then connect the bump 2D node to the normal input. So connect the image output to the bump map input of a bump 2D node. And connect the bump 2D node to the normal input. And set the bump height maybe to something like 0.5 centimeters. And now the bump mapping is visible on the surface. For normal textures, you would connect the normal map texture to a normal map node and connect the normal map node to the normal input. For now, disconnect the bump 2D node. Then we have this anisotropy tangent, which lets you specify a custom tangent map for specular anisotropic shading. For now, hide the shader ball and unhide the abstract object here, and set the second standard surface shader as the beauty shader. This one is a transmissive shader. Let's come down to this advanced section. We have this caustics checkbox. Generally speaking, because of the Arnold's nature as an unbiased ray tracer, it is really hard to get crisp, sharp caustics, but a general caustic effect can be achieved using this checkbox here. Let me show you two renders with and without caustics. In the first one, caustics is disabled, and in the second one, it was enabled, and you get this slight caustics effect, which can add to the realism. For now, I'm going to disable it. Next, we have internal reflections. For this, let's unhide the shader ball. If unchecked, it will disable indirect specular computations when transmission ray depth is bigger than 0. Next, we have this exit to background. To see this better, let's set the transmission ray depth to something like 4, which is fairly low. Now, because we don't have enough transmission ray depth, we start to get this black glass panes. But if I turn on this exit to background option, and this will cause the standard surface shader to trace a ray against the background or environment. When the maximum specular or transmission ray depth is met, it will return the color that is visible in the background or environment in that direction. When the option is disabled, the shader will return black when the ray depth is reached. So this can be very useful to make those black areas less visible when we don't have enough specular or transmission ray depth. I refer you back to the specular and transmission ray depth lesson in the second section of the course. Let's go back to our first standard surface shader and come back to the advanced section. Indirect diffuse controls the amount of indirect diffuse lighting received by the shader. If set to 0, the shader would not receive any indirect diffuse lighting. Now, if I set it to 2, the shader gets twice as much indirect diffuse lighting. 1 is the physically accurate value. Indirect specular controls the amount of indirect specular rays received by the shader. To see this better, let's set the metalness to 1. Now, if I set the indirect specular to 0, the shader won't receive any indirect specular reflections. And if I set it to something like 2, we get twice as much. This and also the indirect diffuse should stay at 1 to keep the material physically plausible and energy conserving. And finally, we have this ID section, which is related to Arnold AOVs or arbitrary output variables. And this allows you to create up to 8 shader-based mattes for any shader. Let's say I want to create a white matte for all the geometries that have this shader. I can change the ID1 color to white. Now, if I go to the render settings and open up the AOV section, in the inactive AOVs, you can find these standard surface IDs. Let's add the ID1 to the active list by double clicking on it. Now, if I rerun the IPR, we should find this ID1 AOV in our AOVs list, which basically contains this white matte for our shader, or for all the geometries that have this shader. We get back to this topic in the rendering section of the course when discussing AOVs. So in this lesson, we learned about geometry, advanced, and ID sections of the standard surface shader. See you in the next one.